Greetings, my fellow Almontians, and welcome back to Broadcast from the Bunker. Today's hot topic, how are sediments eroded on the Earth's surface? Alright, our due now is 32 to 35 in the GC, so meet me there. Alright, hopefully you spent some quality time on these. We'll start out up here on 32. It says the diagrams below represent the plastic hemisphere models. We use these in class, right? The celestial spheres. It shows apparent path of the sun across the sky on June 21st. Please underline that, right? Summer solstice for observers at 4 different locations on Earth, right? We have the equator, Tropic of Cancer, New York State, and the Arctic Circle. Z is the zenith, right? That's the highest point in the sky. So let's see what it wants you to do. First one says, which location will receive the greatest intensity of insolation? Well, intensity is like strength of sunlight. And that's going to be directly related to the highest sun, right? The higher the sun is, the more intense the energy is going to be. Well, which path has the highest of them all? Which one is closest to the zenith? You got to go right there. Tropic of Cancer, it actually hits the zenith, so it would be the most intense sunlight. Okay. All right, and it says 23.5 degrees north already, but why not write it in to reinforce that? Okay, 33 in 3 months, so 3 months from June 21st, right? So that's June, July, August, September. We're at an equinox month there. In 3 months, the length of day in New York State will be, well, on June 21st, that's our longest day. So when we go to an equinox day, the days start to get shorter. So certainly shorter, that knocks out A and B. Well, which one is it though? Is it shorter because the sun will rise and set further north or further south? Well, go to the diagram in New York. And if you look closely at the diagram, this is June 21st. The sun is rising north of east and setting north of west. As we head toward winter, the sun will start to move a bit south. On an equinox day, it will rise due east and set due west. But the days will get shorter because this arc will literally get shorter and lower, and it'll head toward that south. Okay? So shorter because the sun will rise and set further south. 34, at which location will the longest noontime shadow be observed? Well, remember, folks, if you want a long shadow, then you have to have a low sun. Well, which of these has the lowest sun? Take a look. The lowest sun would be right there, the Arctic Circle. And that shouldn't be a surprise, right? So far north of the equator, you're going to have a very, very low sun. The last one, 35, is asking you which position shows the Earth during summer in the northern hemisphere. That's going to be summer, so we're tilted toward the sun, right? So this one is tilted toward the sun. That's definitely your summer in the northern hemisphere. And notice it's also furthest away. We are furthest from the sun in the summer. And this magical distance, right when you're furthest away, A for away, aphelion. So jot that in there. All right, position A is choice C. And that distance right there, write it in, that's aphelion. And that's A for away. Okay, any further questions on that? You know what to do, right? Leave them in the comment section down below this video. All right, let's jump into the lesson here. All right. And once again, folks, thank you for your continued persistence and patience with the internet issues. A lot of good assignments are coming in, so I appreciate your hard work. Okay, Today we're talking about erosion, and of course weathering and erosion sculpt the Earth's surface. They make these beautiful landscapes, but they can also be quite destructive. So you take the good with the bad, of course, and that's what we're going to be looking at today. All right. Check out this video. This was quite a mass movement that occurred on a highway upstate. And you tell me, first off, how is the land moving and what could have caused this? Check this out. Imagine if your car was right there. That would have been a bad day. Alright, so observe what's the weather like, what possibly could have caused that, what conditions. I think everybody can see how moist it is, right? You can actually see the rain in the air there. Pretty amazing stuff. And that, of course, if your car was in the way, certainly would have swept it right off the highway. Okay, make sure you read that through. Gives you a little background information. Oh, by the way, that, of course, hopefully you realize that was triggered not only by gravity pulling it down, but there's so much rain going on, it literally soaked the ground and it made it all mud, and that loosened everything up, and it didn't take much more to pull it down. Okay? All right, so here we go. How do we define erosion? Well, there it is, transporting weathered sediments from one place to another, and these are all pictures of Mother Nature doing just that. There are 5 agents of erosion, but the number one agent of erosion is water. All right, it is responsible for carving the Earth's surface, transporting sediment further, farther, faster than any other sediment there. So there it is. Number one is water, right? Rivers and streams. Glaciers, well, we don't see those in Elmont, but glaciers are massive agents of erosion that transport material slow and steadily. In fact, Long Island, right, where we live, all of this material was transported here by a glacier at the end of the last ice age, right? When that glacier melted, all the material was deposited, and that's what we're walking on today. Wind, as you know, wind can blow sediments quite a distance. Gravity, of course, pulls things down. Ocean waves, you've all been at the beach. You feel the water, hitting your legs, where you can feel the sand scratching your skin. These are all agents of erosion. Okay. Who is this mysterious force behind the scenes here? Well, of course, gravity, as you know, pulls things down toward the center of the Earth. Gravity will make water flow downhill, cause glaciers to flow down a valley. It's the reason that the wind will eventually drop the sediments after being blown a good distance. So gravity, of course, a major player there. All right. How are sediments transported by gravity? This was a huge slide there. You could see the town getting devastated down below. There was a huge mudslide, I believe it was, in Armero a while back, South America. And the residents, it happened in the middle of the night. A volcano erupted. It melted the ice on top of the mountain. All that melted ice, the water came downhill, turned into mud, and killed thousands of people overnight. You don't think about erosion as being responsible for thousands of deaths, but it was a tragic accident. So mass movements, this is called a landslide. You can literally see the land sliding downhill there. That, you can see there's a liquid nature to it, so they give that one's name a mudslide. Of course, there's snow slides as well, right? We call them avalanches. Check out this skier here. He was tempting fate. It was a fresh snowfall, and they wanted to go skiing during a fresh snow. But fresh snow is very loose, and often an avalanche occurs. Watch what happens to this guy.
Okay, I'm going to jump.
Buried alive. This video, posted on the internet, appears to show a skier being swept into an avalanche as he takes on a mountain in Alaska. The incident apparently took place last
the
spring.
snow cracking
The
there.
skier, with a camera mounted to his helmet, drops in and starts making his way down the mountain. Then he hits a patch of shifty snow, kicking off an avalanche that completely swallows him in. His camera captures it all and picks up his audio.
So you can see the body cam totally getting buried in snow, right? He's obviously rolling over and over. You can see the blue sky once in a while, and it gets darker and darker. And at this point, he's completely buried.
You hear him gasping for air for about 4.5 minutes. Some of his fellow skiers watched the whole incident from the top of the mountain and came to his rescue, digging him out after the avalanche stopped. For MSNBC.com, I'm Dara Brown.
He's real lucky. He didn't have much time to survive. The weight of that snow pushing on your lungs, you can't breathe. He's just excited to be alive right now. So thank goodness his buddies were paying attention there. So that's an avalanche. This one of the state quarters, you might have this one in your pocket. This was a famous rock formation in New Hampshire. It was called the Old Man on the Mountain. And it looked like a profile of an old man, but then one day, one spring morning, after a freeze thaw, right, frost action, brought it down. Well, that's what it did look like. But if you went there now, that's what it looks like today. Completely gone, totally brought down by the force of gravity. Frost action cracked the rock, and down it went, right? They call those rock falls or rock slides. Okay? And then a slower one, which doesn't get as much press, but it's responsible for most economic damage, they say. They call it creep. And this constant slow downward movement of soil will break power lines, gas lines, and cause millions and millions of dollars worth of damage over time. You can see the trees, they'll bend toward their light, right? That phototropism as the ground slowly moves beneath them. All right. Regardless, describe the appearance of these sediments. If you're deposited by gravity, well, you're not getting transported very far. You're just kind of dropping down. So you stay all angular, jagged, and sharp. You're not getting rounded out in a river over many, many years. So if you're just deposited in a gravity pile there, you look kind of jagged and angular. And if you get cemented together, then you wouldn't make conglomerate. You would make breccia. Okay? And there it is. Irregular shape, sharp edges. Okay. Make sure you're getting your notes filled in. Some of you might have seen the movie The Mummy a while back. There's a funny scene where they have a little fun with wind erosion. Check this out.
I need a new job.
And there it is. Look at that. A kiss saves the day. None of that stuff at this time, folks. We need any transmission of viruses because of that stuff. But anyways, that was a little Hollywood fun with wind erosion, right? The faster the wind blows, the bigger the sediments it'll pick up, and the further it'll transport them. So how is wind an erosional agent? Well, it carries sediment quite a distance. Of course, it depends on the size of the sediment and how fast the wind is blowing. Greater the velocity of the wind, the larger it can carry, right? Direct relationship right there. Usually occurs in your drier climates, right? Beaches, deserts. You've heard the expression a sandstorm. Well, that's the real deal. When the wind picks up and the sand particles get suspended in the air, you got to cover your face and you got to seek shelter. Okay? You can actually see the direction that the wind predominantly blows on these ancient Egyptian sculptures because it'll take this linear pattern in it. And over time, it kind of erodes it away. All right? There's a classic sandstorm coming into a city right there. Well, you all know the Rock, right? Well, even the Rock, as tough as he is susceptible to wind erosion, right? As all rocks are. And there it is. You'll end up getting pitted and, of course, wearing away. Okay? How does it do this? Well, it's called abrasion, and the predominant wind direction will beat against the rock until it literally changes its shape. And when it does, they call it a vent effect. And it takes on this cool little shape there. Okay? That's a beautiful place, Arches National Park out in Utah, where the wind constantly sculpts the landscape. The sandstones out there get pummeled by the wind over time. This one is called Delicate Arch, and you better get there soon because not much left holding it all together. And it too will fall and become part of the desert landscape. Okay? Beautiful, beautiful picture. So again, erosion is a destructive force, but it makes beautiful pieces in nature. Okay? More resistant rock layer remains on top, the least resistant on the bottom. It also creates this very cool phenomenon. Check out on the top right, over time, as the sand is removed, you'll have the bigger sediments will settle down, and it makes what's called this desert pavement. And it's pretty wild because all of a sudden the area will get lower, but also easier to walk on in a sense, right? They call it deflation. It lowers an area's surface by removing the sand and the smaller sediments to another area. You can see those pittings there. You can see it's totally rounded out. Not as much as water, but it does round it out as well. Okay? Rounded and pitted. Sometimes you'll see the word frosted. This is a gorgeous, gorgeous rock formation in central Australia called Ayers Rock, and it's a very spiritual place for the natives down there. It's enormous. I know from the picture, if you just look quickly, it doesn't look like much. But it's over 2,800 feet high, which is almost 3 Empire State Buildings tall. And the other neat thing is it's about 550 million years old, which is right around the Cambrian explosion, right? That modern explosion of life on Earth. It's a sandstone formation. The red is exaggerated by the sunset, of course, in this picture. But it is red because of that element that rusts, that oxidizes and turns that orange color. And the element I'm talking about, of course, is iron, right? And there it is in central Australia. Very, very beautiful amidst a flatter desert landscape. All right, so let's wrap it up with a couple of Regents questions here. The photograph below shows farm buildings partially buried in silt. Silt is a particle a little bit smaller than sand. It's a little bit lighter. It's easier to be blown in the wind. Which erosional agent most likely piled the silt against this building? Well, hopefully you chose choice 3. All right. Over time, all these old communities that were abandoned will be taken back by nature, and wind erosion is just one of the ways that it'll do that. Diagram below shows sand particles being moved by the wind. Now we're going this way. At which Earth's surface locations is this process usually the most predominant type of erosion? Well, hopefully you chose deserts and beaches, right, where you have more sand and can be carried great distances. Okay? Well, I hope that made sense to you folks. If you still have questions, right, don't forget, simply type them into the YouTube section below. Or, of course, you can send them out via Remind at this code here. See you next time.